Okay, so we ended up with this needing to be factored by grouping, which again, I will help if you need it, me to. And you're going to factor it and get this, and then you're going to know from the zero product property that you've got solutions at -1, -3, -2, and +2. You will, of course, check your answers. I'm going to blast through this because you can pause the video and check for yourself. And I will recommend that you set up the equation in your graphing calculator and just plug in the answer choices as you go. Like you'll do stow, you'll use the stow button, but we'll check -3. And you always know an answer works is if your equality is true. Does -7/2 equal -7/2? Yes. So there you go. We'll test -2, plug in all the answers where the P lives, and you'll get an equality that is true. And if so, your answer works. And we will check our third answer, plug in 2 into parentheses, which keep you safe, and we'll click, and check. The equality is true. You should always check your answers on a test. All right. The rest of the time is up to you, but a test is not, something you want to play with. Please pause and do this one for yourself. And if you got B, you are fine. If you did not get B, ask me for the solution. I will write it out for you. And we've got the old word problem, which I know you love so much. So here's the deal. Aaron is going to add a solution to 16 ounces of a different solution, meaning different in terms of quantity of brine. And then he's going to make a third solution from the first two, which is now 50% brine. And it sounds like you're going to need a table, which you are. I happen to know that. And so you set it up based on the percentage and quantities, what you know and what you don't know. And we know that originally he has 16 ounces of 10%, so the amount of brine is that. And we don't know what he needs to add, but we do know it's 80%. And we do know that the final solution is going to be a combination of the first two. This plus this gives you that, and this plus this is going to give you that. So now you can write it as a fraction and do math. We do know that percentage equals the amount of the solvent in the total solution. So you'll write a proportion of that, and you'll set up our equation. Here's our final solution, and we know that we need it to be 50%. The amount of brine over the total solution. Mrs. Dudix would love this problem. And then you're just going to do the math. We'll simplify, and you can cross multiply, or you can do you. The lowest common denominator is this, and we know it's a percentage, so either way, you can run the number with the 100 or without, whichever makes you more comfortable. You do math, you factor, and you end up with this. You do math and you distribute, and you get everything on one side. We get x alone because that is our job. We'll divide everything by 30, and we will get a quantity of solution. And we know it's 80% because that's what we know he's adding. You will, of course, check your answers, and we'll plug the 21 and 1/3 into where x lives. And we'll do math, and with a calculator. I'm rushing this one. In the future, I'll try to have my calculator out and encourage you to bang out the numbers for practice. But when you are done, is your equality hold true? It does. So you did it right. Here's one for you to practice. No, and normally I would say do it without looking, but in COVID life, you can always look. So maybe if you want to, hopefully you take notes when you watch these and you want to look at your notes, or if you just watch them, you can go back if you forget what to do, but you should do this for yourself because you will see it again, just saying. And B, the letter of the day. If you didn't get it, let me know and I'll tell you how. Last problem, I actually have more, but I'm only going to do this last one. Lila is swimming for 5 hours. Lila has no other life. She's COVID life. In a stream that has a current of 1 mile per hour. So that means when she's swimming with the current, she's going 1 mile an hour faster. And if she's going against the current, then the current is taking away from her personal speed. So we're trying to find what her swimming speed is in still water. And they gave us a bunch of information, which of course we can write an equation from. And these always require distance equals rate times time. And distance divided by rate equals time. And we're looking for, we're going to need time. We're actually looking for her speed in still water, but we do need time. And we're good. So we know that R is going to be her speed in still water, which is what we're looking for. And with the current R plus 1 against the current R minus 1. And we can put everything in terms of time because we can make the equivalencies time, but our variable will be her speed, which is what we're looking for. So when she's with the current, I think these are backwards. In my mind, against the current would pretend the words are backwards. Either way, she's going 2 miles either way, so that's distance over rate. So distance, I'm sorry about the words. Okay, either way, it's going to work because it's plus 2 plus 3 is 3 plus 2. And this is her rate. So she's got distance over rate equals time, distance over rate equals time, and time plus time going one way plus time going the other way will give us their total time. And you will do the math and solve these. This will be stupid easy after the other ones. And you could do R plus 1 times R minus 1, or you could know that that is this, and you cancel out the things you don't need. And we end up with a very nice equation, at which point you obviously, I hope it's obvious, distribute and simplify. And we're going to need it to be all equal to, we'll set it equal to 0 because we're going to need to solve it. But at that point, you can't factor out of 5, and it turns out there's no nice factor for it. You're going to have to use the old quadratic formula, which I hope you remember. I made you sing it. But again, in COVID life, you can look everything up. So there it is. And you're going to plug in your numbers. B is -4, A is 5, C is 5, C is 5, whatever. There it is. It's all good. You plug it in, you do the math, and you get some seriously ugly numbers. And there are 2 of them, one the plus, one the minus. And yeah, factored there. Then we'll simplify it. Then we'll turn it into 2 possible answers. The problem with this is negative speed. Speed only has a magnitude. Velocity can have direction, so velocity could be positive or negative, but speed only has a negative, so it only matters positive. So the answer is about 1.5 miles per hour. You should, of course, check your answers, and it won't be exact because we approximated, but it's close enough, and that'll do it. If you have questions, you know the drill. Have a nice day, and as always, I miss you.